I'm Patrick Kennedy. This morning, I'm interviewing Bryant Cruse of New Sapience. Thanks so much for joining us, or this evening, your time. We're going to do a short interview, about 21 minutes, which isn't nearly enough time to cover everything we should need to cover. It'd probably take 2 hours, but this is meant to be an introduction to New Sapience. We're going to go over the team. It's a world-class team. We're going to go over the technology, which is intriguing and thrilling technology. And finally, we're going to go over the market, which we were talking before the call started. It's sometimes hard to define with AI. What exactly is the market now? What will it be in 2 years? What is really realistic in 5 and 10 years? So it's a ton of information to go over. It's just an overview, a primer for those prospective investors in New Sapience, which is live now on Dealmaker. If you have more questions, and I'm talking to the audience now, about the team, about the technology, about the market, feel free to reach out to QCM. We're doing marketing for New Sapience, or directly to New Sapience, and they will get all your questions answered. So with that, let's dive into it. Let's talk about the team, including yourself. Can you tell us a bit about the top 2 or 3 people on the team and why they really are world-class?
Investors come in, they basically look at 3 different things for us. Is the technology plausible? Is the team credible? And then the market, if it is, it's a really big deal. So yeah, these 3 things. As far as credibility, there's a bit of people have paused today because everyone's talking about AI, and literally billions of dollars are funneling into AI. And you look at our company of about 10 people, 15, between 10 and 15, and you say, well, how can that possibly be competitive? Right. Well, the reason is that we're doing something entirely differently. We are the true 0 to 1 contrarian company. But we're not, this is not our first rodeo. Between on our board member, we've got, I myself have 2 previous startups that exited, both in the AI area. And both of those were in applying AI techniques to space operations, about as intense as you can get. Both of those companies were successful. They were created. The team has taken a number of ideas, new technological ideas, turned them into technology, turned those technologies into products, and brought those products to market, and made millions of dollars for our investors. And we've been around quite a while. One of our board members, Bill Readdy, deputy administrator at NASA for astronautics, 3-time trips to the space station himself. He and I go back almost 40 years in Space Command. That made us decades. We've known each other really, really well and collaborated on space applications and AI applications. First outside investor, Bill Bandy at DARPA, PhD physicist. He used to talk about going down the road to the AI section at DARPA and saying, when are you guys going to get those machines so we can talk to them? So he recognized very early on that when real AI came along, it would look a lot like what we've done. So we sometimes say that this is the only AI company founded by rocket scientists, which include a number of us. It's not an exaggeration at all.
And what?
Yeah, go ahead.
Oh, I'm sorry. Can you talk about the total amount of exits? It's some kind of staggering number, isn't it?
It's about 350 million. The biggest one was Bill Bandy, who I said at DARPA, who they pioneered RFID chips at a company called Matrix. And then my 2 exits are more modest, but $10-15 million, things like that. So
350 million. I talk to a lot of investors on all different platforms, Dealmaker, Start Engine, Republic, and the number one thing they're often looking for is success with previous exits. The thinking is, regardless of the field, someone captured lightning in a bottle once, they have the possibility to do it twice. So that's encouraging.
Well, most startups fail. The fact that I have 2 successful ones, this is my 3rd one, that's statistically quite an anomaly. We know what we're about here. This is not our first rodeo.
Great. And talk a little bit more about your background in detail. We got time to unpack it a bit.
Well, I came to AI in the mid '80s. I was trying to solve a very real problem. Uh, AI has always been about, typically been about some theoretical person, theorist who had an idea about what human intelligence might be, and they thought they could write some software to mimic or imitate it. And so, it didn't work. So it has worked, but they call it AI anyway, because nobody wants to come and say, well, I didn't work, that didn't work, let me try something else. So they call that narrow AI, and then they try something else. In my case, I wanted to put knowledge, expert knowledge of spacecraft engineers into a spacecraft ground system to automate the analysis of telemetry coming down from the vehicle. Humans aren't good at that. Doesn't matter how much training you have, how much knowledge you have, because we don't keep up with real-time data. We don't keep up with lots and lots of numbers. So I wanted to combine, computers were good at that, but they don't contain knowledge. They just process data. How could I thought that this is my approach? How can I get the knowledge in my head? Because I know what the numbers meant. I just don't have the computer's speed and reliability to keep up with them. So I approached it from that effect. And it took 2 different companies and 2 different technologies before I really got a handle on that problem. So the other thing that was really, really interesting is that when we realized at New Sapience, and as New Sapience was getting some momentum here, that if we were going to put knowledge of the everyday common sense world, how do you scale that? The old-fashioned expert systems try to do that, but they try to do it one fact at a time, which meant to millions and millions and millions of separate assertions. You could never really build a practical application there. That's why symbolic AI expert systems failed. It just didn't scale. So we needed something, a compact way. So we said, well, what is knowledge? We looked into our minds and we saw all these ideas. If there's an idea for every different word, English has 1 million words. How are you going to craft 1 million ideas or any subset of that? So, but we looked at it and said, well, ideas, complicated concepts are composed of simpler concepts. And if you start breaking them down into simpler and simpler concepts, shouldn't you eventually get to the atoms of thought, ideas that are fundamental, that are basically built into human brains, and of which all other more complicated notions and ideas are composed of? Well, this was a natural for me ever since my undergraduate days at St. John's College, where we studied the Western canon, Aristotle and Plato and Kant and Hobbes and all the people who had things to say about the relationship of our ideas and our minds to reality. And we recognized that it was feasible to take that approach, to see if you could identify 100 or 150 so core ideas that could then be classified according to their connection properties. That the idea was some ideas will connect to other ideas and make a more complicated idea that corresponds to reality, and some don't make sense to do that. So without my background in epistemology, and a rather radical epistemology, as it turns out, epistemology that is baked into our hardware is quite unique. So this was one of those unlikely combinations of experiences and talents. It didn't have to come out that way, but it turned out to be vastly different than what everyone else was doing. And our technology today, while we are aimed at some of the same problems and even having success where other people are not, there was absolutely no real underlying connection between what's going on today in AI, machine learning, artificial neural networks. We don't take that approach at all. It's a fundamentally different approach. And the best way to describe that, I think, that in an easy to understand way in that approach is everybody else, including the machine learning guys like Jan LeCun and everything, they're building artificial brains, which is not an unreasonable thing to attempt because human brains are the only things we know that have intelligence in nature. So AI has always been about mimicking those things. But the problem is that's really hard. And we have neural networks that are in the computational capability of of an early vertebrate, if not worms. And we're trying to, in a neural network through algorithms, recapitulate billions of years of neural and cognitive evolution. I mean, it's been about 4 million years of cognitive neural evolution between us and our closest relatives. So how are you going to figure that out and reverse engineer that? We think it's kind of hopeless. So we said, wait a minute, let's take the opposite approach. Yes, top down, expert systems was supposed to be top down, but that was fundamentally flawed. Why? They had no epistemology. They had no theory of knowledge, no theory of that knowledge is a model. So we look at that model and we say, well, how can we test these models and see which is a good model or a bad model, just on the surface of it? Let's say you were walking across a beach or an uncharted planet and you came across something that you say, this was obviously built by intelligence. Could I reverse engineer and build that without knowing much about the people who made it? Well, that's feasible. So what we do is synthetic intelligence, in the same sense that, say, a synthetic diamond is a real diamond, same carbon lattice as a natural diamond, but made in a lab through direct engineering. Doesn't happen. The way it's made is not recapitulate the way they're made in nature. That takes 15 continents smashing into each other, millions of years of pressure and heat. It can make them in the lab much more efficiently. So we are creating the end product knowledge directly. And to there we see, in a sense, a commonality of goals with people like John Lucan, who comes right out and said, he said all along, we're never going to get real AI until we can build models of the world, models of the common sense world, and put them into a computer. But the difference is, he's trying to create an artificial neural network, a brain that can create such a world model, kind of, out of raw data, starting with a blank slate. Well, that is really, really hard. And even so, there's a huge gulf between the models he's envisioning. The models he's envisioning are really 3D spatial models, whereas we go directly to cognitive models, where we can talk about abstract ideas, very abstract ideas, and we can put them directly into the computer to reason about. So even where he is and his notion of the goal, he has a really hard problem. I mean, humans are intelligent animals. He's trying to build the animal part first. We're just going to the intelligent part. Forget about the animal. We're just putting the end product of human intelligence, knowledge, into a machine. So the results we have today are extremely promising. And that's the third thing. Yes, we're credible as a team. Not a First Radio. We're not not Elizabeth Holmes. We've been around for decades and had real success in the real world. The technology, yes, I don't expect you to grasp, but it's eminently plausible what we're doing. There's no reason to think this couldn't be done. I mean, it's just no one's ever tried it this way before. And finally, as far as the market, we don't see any limitation to how much knowledge and how much intelligence reasoning about that knowledge we can put in with our technique. With a very small team, you can sit and we can have a conversation with the Sapiens that runs on an iPhone. The entire code base is running on the phone. I mean, you compare the amount of time and energy and expense to build these rather, slick, but empty LLM models. It's just no comparison. I was saying the other day about the LLMs, and the problem is they're now estimated that some of the studies have shown that they're actually wrong 40% of the time. But people don't see that because it always sounds good. So unless you're an expert in the field, you won't know that it's giving you a sound-like answer instead of a real answer, because it doesn't know. But if you are expert, why are you using it in the first place? So there's a real problem with those.
Okay, so that's a lot you went through, the team, technology, market. Let's go back to the team just for a moment and then work ourselves back to the technology and the market. No problem. I mean, they're all connected, obviously. So the team has a collective $350 million.
Something like that.
Yeah, so approximately, which is impressive. Let's talk about William F. Readdy. What is he's a chief partnership officer. Can you tell us a little bit about him?
And the board member.
Okay.
Well, Reeds and I go back, as I said, a long way. What he's looking for is when we get to the technical baseline, to start doing commercial demonstrations. And we have almost an unlimited number of markets when you break it down, because if you really look at it, in essence, what synthetic intelligence is, it's a new way of programming computers with human knowledge rather than just data and information. But to take a new automated knowledge technology into a vertical market, particularly one that may have very stringent requirements for success, you've got to show them a demo, you've got to be credible, and you've got to build something that they're going to be able to relate to. And Bill Readdy is, he's the guy looking at that because of his really very, very broad industry experience from all this years at NASA and aviation as a naval test pilot, as administrator, and worked in very many difficult engineering things. For instance, he was in charge of upgrading the space shuttle for glass cockpits back in the day, and many other things that we worked together. We served together in the Naval Reserve, in the Naval Space Command. I was his executive officer back when there was a Naval Space Command. So that's what he's also on the board. He's also really one of the first person came to me and said, "I want to put some money into this deal." So, he's been a tremendous believer and supporter of our technology ever since. So he will be I think, the gatekeeper and open the door to that whole area of marketing, that whole huge market where you have complex systems that have data and commands and data and remote mission and require automation, not just space and deep space vessels, but any place. Today, one of the entry level applications for us is any way you have a bunch of people sitting in a room looking at screens operating something like network analysis or intelligence gathering or space operations, network operations, power plants, large industrial systems, any place like that. He has great credibility to help us into those markets because of all the complexity of these kind of markets and the difficulty and the payoff of getting it right and the penalty for getting it wrong. Space operations is probably the pinnacle. If you can do space, you can do anything.
You can do space, you can do anything because there's no backup. You can't just call in a second unit.
That's right.
Okay. It's a harsh environment, obviously. Let's stay on the team for a bit then, because I think the team is as fascinating as the technology. You've got Karsten Huneycutt is the chief software architect. Can you talk a little bit about him?
Well, Karsten, I actually connected with him right out of just a few years after he graduated from Duke with a dual major in computer science and Russian. So he's also a linguist, which turns out to be very much apropos to what we're doing at New Sapient today. But he's one of those people. I was introduced to him by an employee of mine at a previous company who was herself a programmer. And she said, "Brian, I hear you're looking for somebody. This guy is the most brilliant programmer I have ever met." And, for a hobby, he does things like study Mandarin Chinese and things like that. But he is a brilliant computer scientist. And we had a different kind of problem to solve. It wasn't like a conventional programming side of it, because for us, the curation, there's on one side, you curate your knowledge directly from your own mind. You look into your own ideas and say, how can I get my arms around these concepts in a way which has no linguistic baggage, that if I'm thinking about how to model a tree, build a model of a tree, which we actually end up putting into a directed graph structure, it's got to be exactly the same whether I'm thinking in German or Russian or English or whatever. So that's one challenge. It's not programming. It's thinking. I call it applied epistemology, actually. But on the other side, we have to reason about this knowledge. Once we put it into this structure, you have to think about it, reason about it, draw inferences about it. And for that, you need logic and you need the language. Now, computers are good at logic, but in the past, all computer languages were designed to do data and information. Even when like Prolog, which was designed to be an AI language and do logic, it was designed to embed each rule, wasn't designed to be a single assertion or fact, no scaling. So Karsten ended up writing a language, an entirely new programming language. I remember early on, I said something about, "Well, that's pretty impressive that you can write a language." And he said, "Well, let me tell you something, though, Brian." He said, "I think people go out and write a new programming language simply because they can. I think that's arrogant. I would never write a new programming language unless there was not any other language out there that would serve the purpose."
Okay, so let's move on then back to the technology. So again, I'm a layperson, but I'm talking to a lot of AI companies and AI investors, and the critique of these large language models, and correct me if I'm wrong, is that they are kind of number crunching, just enormous amount of information without any actual, let's just use the most basic term, value added. There's not actually any insight into the information. Is that accurate?
Yeah, they're just statistical algorithms doing what computers have always done, crunch numbers and statistics. In this case, they're calculating the probability given a word based on the training set, which word will come before or after that word, and same with a sentence and same with a paragraph.
Mhm.
So they create a stunning illusion of communication, which is what language does, right? Language doesn't contain knowledge. It's a protocol for transferring knowledge from one mind to another, right? As you and I are talking, we're taking ideas out of our mind, we're encoding them into language messages and sending them back and forth and decoding them because there's ideas in my head and there's ideas in your head, transferring back and forth. LLMs have no ideas in their minds. They don't have any world model. As Jan Meta would tell you, there's no model in there of the world. They're just calculating statistical probabilities of word sequences. So they know nothing. And so they always come up with a great sounding right answer, a great right sounding answer, but they have no idea whether it's right or not. I pointed out in a expo not long ago that this idea of saying that they hallucinate sometimes is ridiculous. They hallucinate all the time. Everything they do is made up. You know, it's that sometimes statistically what they make up corresponds to, you know, what a human would say is true. And believe it or not, you know, lately some studies have shown they're actually wrong about 40% of the time.
Mhm.
So now people say, well, but it's cool and it looks like communication and it does help me crank out these low level, you know, mediocre interface code or mediocre documents. I pity people who have documents whose job is so crummy that their job is to create out mediocre documents in which ChatGPT's version is actually acceptable,
Mhm.
even though everything that they come up with sounds like it's processed cheese as far as language is concerned.
Yeah,
But they're
Mark.
parrots.
Okay. I just say, yeah, in marketing, there's this whole idea, particularly among young people, that to run a marketing company, I run a marketing company, couple, through, chat GPT, and it's absolutely ludicrous. I mean, um, it's kind of, in my opinion, it's an admitting defeat that you can't train human beings to do the most basic things.
Well, that's what I tell people. Listen, if you're getting better at generating prompts and generate text, you'd be so much better to pick up, you know, a good book on grammar and study writing a little bit. Just hone your writing skills. You know, you'd be much better spent.
Read Plutarch's Lives and take a week and
Right.
Uh, okay, so let's talk about the market then. So, I think a lot of us understand that it will transform a lot of different areas, but sometimes wrapping our minds around the timeline is difficult. And then also for New Sapiens, are we talking about having like a viable technology that would be applied in use the space being the ultimate test? Would that be 2 years from now, 5 years from now, 10 years from now?
We could easily field our first space application within 2 years. The reason that the thing that is holding us back now is we're putting all our resources really into demonstrating the core technology by solving what has been kind of the holy grail of AI, and that's natural language understanding.
Okay.
Not apparent generation of text, but actual being able to read language, comprehend, have a conversation. And you know, we are making real strides in that area. So we hope to get to what we think of as kind of the tipping point technology demonstration there within 12 months,
Okay.
within a year, based on our current fundraising profile, which has been very encouraging. We're now on our second crowdfunding thing, and we look like we'll hit the million of $5 million on this raise, you know, sometime next spring. So that's really encouraging. So we're hiring and we're expanding and building up the team and training them in our unique epistemological engineering and moving toward that demo. Now, from the time we get to that demo, then we'll have a bit more bandwidth to look at a space demo or a healthcare demo. We are talking about a memorandum of understanding with somebody in the healthcare industry right now to build a Sapience application for basically elder care.
Okay.
And you know, we might we got some interesting feelings doing something similar in operating drones. Drones, it's a topical topic or a timely topic. But anyway, we could do some amazing things by putting an intelligence inside a drone, obviously. So there's lots of markets out. So we're not talking 10 years, 15. We're not really talking R&D here. We're building out this model today. We know how to do it.
So you're raising 5 million on Dealmaker. We'll obviously include the link to the campaign, and the goal is to use that to scale up for a model in these different fields: healthcare, military, space, and so on. Is that accurate?
Yes, but also we're also looking at a consumer product.
Okay. Okay.
In two ways. One, of course, if you have something that truly understands language, there's obviously a huge market that's already been validated and vetted for us. That is, all the big tech companies are running to their quote intelligent assistant, intelligent agents, and okay, you know, we'll see how good they are. You know, the jury's still out, and then of course I'm very skeptical. But then they say, well, don't worry, because we're going to get the next big stage of bigger models, and they'll get even better, even if they're kind of crappy right now. Well, again, a lot of skepticism. You know, they got to like build nuclear power plants first, and then they're going to get enough energy, and you know, they're going to be competing with you and I for our energy bill.
Yeah.
And where are they getting the data? You know, I mean, they're already kind of getting diminishing returns. If you look at the, you know, the amount of parameter increase from DP2 to 3 to 4, and 5, which is still not here. It's not getting that impressive. It's really flat. So very skeptical, but they've already created a market. I point out they've created a market for us. So when we can say, hey, look, we can take and put our Sapiens inside Siri and truly understands the meaning of your words and your ideas, and it's going to have knowledge that we put into it of human needs, wants, and desires. And knows what it knows and knows what it doesn't know. One of the most impressive things I point out about a Sapiens is when you ask it a question, it says, I don't know. Because it knows it. ChatGPT never says it doesn't know. Doesn't know that it doesn't know, right? It doesn't know anything. You know, a Sapiens will go into its internal world model and match comprehend what you're asking it. And if it doesn't have it in there, it says, I don't know the answer. But of course, with time, we'll put more and more knowledge into it.
So let me kind of bring this down again for a layperson. So I'm spending Christmas in Bali, Indonesia, and let's say I want to go surfing Christmas morning. A new Sapiens, I would say surf lessons Christmas morning between 10 and 2 o'clock, and would it help me book that lesson?
Ultimately, not maybe a very minimally viable product on day one, but what it would do that nothing else can do. I mean, yes, that's certainly coming, but it needs interfaces for that. It needs to deal with the vagaries of humans and things like that. And with none of that's particularly profound, by the way. The hard part is understanding what you meant about a surf lesson. You know, and it might come right back and say, if you looked at the weather report, Patrick, you know, you can't go surfing today. Those kind of, because it knows that surfing is a sport and that it's dangerous and weather matters and waves, all this stuff. So it can truly be the kind of personal assistant that big tech has hyped for all these years, but never really got anywhere close to it, ultimately. But on day one, it will do something pretty neat. It can do this today. I can pick up my iPhone and talk to my Sapien and say, Helen, I'm taking my metformin. And then I can come back this evening and say, did I take my metformin? Yeah, you took it at 12:32. So as an auxiliary memory, again, doesn't take any training. I mean, even today, you can get 20 different pill minder apps that you can buy on your iPhone, and you know, I mean, all of them are kind of problematical, and you got to learn how to do it. You got to remember to do this. But this is a case where you just get in the habit of chatting to your little Sapien sitting out there on your phone, or your watch eventually, or a little press to talk button eventually, and just chat it up with it as you go along. It's kind of like you're talking to yourself, and it will never forget anything you said to it not today, tomorrow, or 100 years from now.
Hmm.
Your great-great-grandchildren will be asking you, asking you what you did
Interesting.
100 years from now.
So let's talk about then the size of the market. You know, Nivea, I think, is worth what, $30 billion now?
Well, for the moment.
Yeah, for the moment, which is kind of comparable to Apple and Google and the big five. Um, what what do you think the value of the AI market in a rough sense will be in about 2 years?
Well, I think you really have to bound it. Which part of it, like I said, I mean, we think we have a technology that can revolutionize every application that runs on the computer, period.
Okay.
And so that's incalculable. I remember almost 20 years ago when I had this thought that this might be a technology that would be without bounds in terms of uh, artificial general intelligence and automation. And I actually talked to some professional evaluators. And they said, well, Brian, we don't know, what you say, that you can do what you say or not, of course, but if you can, you cannot put a value on it.
Hmm.
Don't ever try to value it. It's invaluable. Its value is incalculable. License it. Don't ever try to put a price on it. Now, if when you get down to particular markets, though, we talk about a minimally viable product, which is just a little bit beyond what we call the tipping point demonstration, which we hope to get to, in a matter of months. We think that it's not at all unlikely that with this development enhancement, a person might be willing, to pay us $5 a month, or even $12 a month for on a subscription basis. And remember, you talk to this thing and it starts being your auxiliary memory. You're not going to let go of it,
Yeah.
right? So how many people? I mean, what's the market there? How many cell phones are there? 5 or 6 billion? You don't. And here's the other thing: because we're so compact, we don't need giant data centers. We don't need nuclear power plants to run them. Um, our technology runs on the user's hardware. Their phones, their tablets, their PCs, whatever. We don't have to pay anything. Our cost of goods sold is just development cost. So our profit margins are going to be wow. So what? This is like this is printing money. This is cash generation.
Mm-hmm. You're referring to these current like ChatGPT and the others, the enormous energy inputs that are required just to keep them operating. I don't think a lot of people are aware, and when I say enormous, you mean just absolutely enormous, which obviously is going to reach its limit. You can't 10x or 100x that because you literally run out of energy to do that. So
that's why they're literally talking about the big tech companies are investing in nuclear power plants.
I didn't know that. That's insane.
Oh yeah,
it's insane.
yeah. Was it Microsoft when we opened 3 Mile Island again, just exclusively to generate enough energy for giant data centers to build their next giant LLM models? Again, I don't know where they're going to get the data, but
Wait, Microsoft reopened 3 Mile Island?
they're planning on it.
Jeez. All right, so we've been talking about 45 minutes. We meant to go 21, but it's been
Oh
fast.
my gosh.
So we got another 2-3 minutes. So I'm just going to kind of do a recap and then maybe give you the final word. So world-class team, not their first rodeo, not and not even the local rodeo, but 350 million approximately in exits, significant number of exits, pedigrees at NASA, John Hopkins, Lockheed Martin, U.S. military, and really, like you mentioned, a contrarian view of the technology, but one that has a lot of benefits, including being energy efficient. You could even call it green tech, and actually having intelligence rather than just basically massive amounts of number crunching. Did I miss anything? It's a lot, but
No.
so let me give you the final word then. So I'm on the campaign page, and we'll obviously include this when we send this out. There's a 20% bonus share discount for anyone investing in about a week from now. So that's obviously next week is Christmas week. Why should someone invest now? Why not wait and see how it goes in a month or 3 months or 6 months?
But here's the deal. Unlike other approaches to AI, first of all, we don't have to hire PhD algorithm designers from MIT. We have $1.5 million starting salaries. We don't need supercomputers. A small team, we think we're going to get this product to market with a team probably of maybe 20 people. We have 10 people now. We're staffing up. And then once we get that product out there, that minimally viable product out there, the cash is going to come flowing in. There's not going to be opportunities to invest in this company much longer. It's just not going to be there because we don't need your money.
Yeah, I helped with the marketing for the first raise about a year ago when you were raising $1 million, and I've seen how much progress you've made, like a staggering amount of progress since then. And now you're raising 5 million, and that's to get to the product. This is
Very likely.
Yeah.
And if it isn't quite getting there, we can prove it. We've done this. We've had two, we'll have another crowdfunding campaign, maybe it's another $5 million, but I don't think we'll have to do that.
Okay. And if someone's interested in investing a larger amount, say 25,000 plus, 50,000 plus, 100,000 plus, is there someone on your team who's willing to do a quick Zoom call with them?
Well, I can do that. We have a couple of people. We have our Erin, who's our investor relations manager. She's just excellent. But a serious investor who's in charge, I'll drop what I'm doing and talk to them. And we have quite a few. We by the way, we do have. You don't have to invest via the TF campaign. We have a series, Reg D accredited investors campaign that's also open.
Oh, you do? Okay, great.
Mm-hmm. And that's normally, you expect to make personal contact and interaction. So
Great.
that's always open until we don't need to raise any more money.
Okay, fantastic. Again, just an overview for everyone, but could be a game changer, a world-class team, intriguing technology, and space is the limit, pun intended. For the market. Thanks so much for joining me today. It's always a pleasure talking with you, Bryant.
Patrick, I enjoyed it very much. Thank you for the opportunity.